Okay, good morning students. Come back. We can go with one more trick here. In this problem, there is a rod slipping on the floor. Of course, one end is on the floor, other end on the wall. All the contacts are frictionless here. Okay, right. Now, this point has a velocity v downward, and when the angle made by the rod with the wall is theta at that instant. At that instant, what is the velocity of point B? That is the question required here. That is the question asked here. Okay. So, what is the velocity of the point B? Now, you know the general procedure. This x and y I can take. X and y are variable. As the rod is slipping down, x will increase, y will decrease. Of course, L cannot change. I can use x square plus y square equal to L square. And I can differentiate with respect to time 2x dx by dt plus 2y dy by dt equal to 0. L is a constant derivative 0. So I can write 2x dx by dt is velocity of B. X is increasing, keep in mind. So dx will be positive. And this quantity dx by dt or dy by dt is very important. Dt is always positive, time keeps on increasing. Dx can be negative, can be positive. But in this case, x is increasing. So dx is positive. That means final x is more than initial x. Or the x value in the very next instant is more than the previous instant. So final minus initial will be positive quantity. Okay, right. So I am cleaning this part here, not required. Here, come back here. X is increasing, so positive. So I will write it as the rate at which x increases is nothing but velocity of B. I will write Vb plus 2y dy by dt. Y is decreasing. That means final y is less than initial y. Final minus initial will be negative. So dy by dt is negative. So V I have to take it as minus V. So there you should be very careful. Okay, right. That's very important point. Some of the places they have missed out these points. Okay, dy by dt is negative here. Y is decreasing. And what is the velocity of this point? It's V. So here minus V. So I can write Vb as, of course 2 will get cancelled. That is 2y. Of course that 2 got cancelled there. Vy. Right. By x. I can write Vb as Vy by x. So I can write it here Vb as Vy by x is nothing but cot theta. Therefore, the velocity of point B is V cot theta. This is by using calculus we got the answer. X and y are variable, L is a constant. That's a simple way, but there are some complicated ways also. Sometimes calculus involves more complicated way. But I will give you a small trick here. Very important trick. Now if I concentrate these 2 points in this complete rod, I know the directions of 2 points only. Point A comes vertically down, that is for sure. Point B goes horizontally towards right, that is for sure. Other points we can't predict. So only these 2 points directions are predictable. Now that is the original vector. The other things will be the component. In whichever direction the point moves, that is the original vector we have to take it. The other thing, whatever you take as a v cos theta or v sin, they will be the components. So v is the original vector. This will be v cos theta, v cos theta, v cos theta. So this will be v cos theta. V cos theta, and this is 90 minus theta, this is 90 minus theta, vertically opposite angles. Now if you check carefully, this is Vb. Now the question is, Vb's component is V cos theta or V cos theta's component is Vb? That is the biggest question here. Look at this carefully. This is V cos theta, V cos theta, V cos theta, any point will have V cos theta, here V will have V cos theta. Now the question is, Vb's component is V cos theta or V cos theta's component is Vb? Should I write VB cos 90 minus theta is V cos theta, or should I write V cos theta cos 90 minus theta is VB? Now which is the original vector? Which direction this point is going? Horizontally towards right. That is the original. The other will be the component. That's what I was telling in just the previous instant. This is going towards right. That is the original vector. This should be the component. That means VB cos of 90 minus theta is V cos theta. VB's component is this. Therefore, VB cos 90 minus theta, I can write properly here, cos 90 minus theta is V cos theta. Look at that here. VB's component is V cos theta. It is not that V cos theta's component is VB, because VB is the original. That point B is going in this direction. It's not coming in this direction. It's not, we are not seeing the point going in this direction. This point is going horizontally. That is the original vector. So VB cos 90 minus theta is V cos theta. So VB will be V cot theta. So only one step you got the answer. Cos 90 minus theta is sin theta there. So we got the answer only in one step without using the calculus. We will come back with more tricks. Goodbye. Good luck. God bless you.